November 27, 1941. Fort Meade, Maryland. Lieutenant Colonel Andrew Bruce stared at the classified intelligence reports spread across his desk, photographs of German Panzers rolling through France that military doctrine said were impossible to counter. The handwritten notes in his journal, discovered decades later in the National Archives, captured a military establishment facing crisis. The entire American tank doctrine is wrong. We have been preparing to fight the last war while the Germans have invented the next one. Our anti-tank guns are static death traps. We need something that can hunt, not just defend. Through his office window, Bruce could see crews training on the M3 gun motor carriage, nothing more than a 75mm gun hastily bolted onto a half-track. It was desperation made steel, a stopgap measure that every officer knew would be slaughtered by German armour. In Europe, Panzer divisions were achieving kill ratios of 10-1 against static defences. The Wehrmacht's armoured spearheads had shattered the French army in 6 weeks, crushed Poland in 35 days, and were now driving deep into Soviet territory at speeds that defied military logic. Bruce had just assumed command of the newly created Tank Destroyer Tactical and Firing Centre. In 10 days, Japanese bombs would fall on Pearl Harbor, plunging America into a war it was desperately unprepared to fight. What none of the generals crowding into emergency meetings realized was that this soft-spoken Texan from Missouri would oversee the creation of the most successful tank killer in American history, a vehicle initially rejected by virtually every armor officer who saw its specifications, dismissed as too radical, too fragile, too different from everything the army believed about armored warfare. The mathematics of mechanized combat were being rewritten in blood across European battlefields. German Panther tanks weighed 45 tons, carried 80mm of frontal armor, and mounted high-velocity 75mm guns that could destroy any American tank at 2,000 yards. The Tiger tank, at 56 tons with 100mm of frontal armor, was virtually invulnerable to any weapon in the American arsenal. Against these steel monsters, the United States Army possessed exactly 0 vehicles capable of reliable penetration at combat ranges. The standard American anti-tank gun, the 37mm, bounced off German armor like pebbles off concrete. 6 months earlier, in May 1941, General George C. Marshall had cut through bureaucratic paralysis by forming an anti-tank planning board headed by Bruce, with Brigadier General Leslie J. McNair taking immediate action on organizing anti-tank forces. McNair, a brilliant tactician who would later die from American bombs in Normandy, understood that static defense against mobile armor was tactical suicide. His directive of August 8 laid the foundation for revolutionary doctrine, speed and aggressive action to search out and attack opposing tanks before they had assumed formation. But doctrine without weapons was merely theory. What Bruce needed was a vehicle that violated every principle of tank design the Army held sacred. While the armoured force demanded heavily protected tanks for slugging matches, Bruce envisioned something entirely different, a vehicle so fast it could outflank any tank, so agile it could strike and disappear before the enemy could react, carrying a gun powerful enough to kill any armour it encountered. Speed would be its armour, mobility would be its protection, it would be a rapier in a world of broadswords. The Louisiana manoeuvres of September 1941 provided first vindication. Despite primitive equipment, towed 37mm guns and surplus 75mm guns mounted on half-tracks, mobile anti-tank forces exceeded all expectations. Umpires ruled that fast-moving tank destroyer units had killed 91% of attacking armour. The success was so complete that officers from the armoured force complained the results had been rigged. On November 27th, Marshall ordered the establishment of the Tank Destroyer Centre, with Bruce commanding and activation of 53 new anti-tank battalions. By April 1942, the centre would relocate to newly constructed Camp Hood in Texas, where vast open spaces allowed proper training for mobile warfare. The early months of 1942 brought cascading failures. The M6 gun motor carriage, a Dodge pickup truck with a 37mm gun, proved worthless in North Africa. Crews reported the recoil would literally flip the vehicle backward. The M3 half-track offered marginally better firepower, but 0 protection for exposed crews. German 88mm guns destroyed them at 3,000 yards, often before American crews knew they were under fire. The M10 Wolverine, based on the Sherman chassis, was more successful but remained an improvisation, too slow for the hit-and-run tactics Bruce envisioned. By February 1942, American forces in North Africa were learning brutal lessons about the reality of armoured warfare. At Kasserine Pass, German Panzers destroyed 183 American tanks while losing only 20. American tank destroyer units, equipped with inadequate weapons and trained for the wrong war, were annihilated. Captain James Miller of the 601st Tank Destroyer Battalion wrote in a letter that survived, "We might as well be fighting tigers with slingshots. Our shells bounce off their armour like rain. They destroy us at ranges where we cannot even scratch their paint." It was in this atmosphere of crisis and defeat that an unlikely partnership emerged. The Buick Motor Division of General Motors, which had been producing luxury automobiles for America's wealthy elite, was about to design the vehicle that would restore American armoured superiority. The M18 originated in Harley Earl's design studio, part of Buick Motor Division. Earl, the legendary designer who would later create the Corvette and establish the very concept of automotive styling, brought a radically different perspective to military vehicle design. On a fog-shrouded morning in April 1942, Earl and his team of civilian designers gathered in a conference room in Detroit, surrounded not by military officers but by automotive stylists who had spent careers making cars beautiful rather than lethal. The initial Army requirement seemed impossible: design a vehicle weighing under 20 tons that could reach 50 miles per hour, mount a gun capable of destroying any German tank, and be mass-produced using automotive rather than traditional tank manufacturing techniques. Army tank designers had already declared it couldn't be done. Earl's team, unburdened by military orthodoxy, saw possibilities where others saw impossibility. The first sketches, preserved in the GM Heritage Center, reveal a vehicle that resembled a sports car more than a tank: low, sleek, with a raked hull and open turret to save weight. Where traditional tanks were tall and imposing, Earl's design hugged the ground. Where tanks were heavily armoured boxes, his vehicle used sloped surfaces to deflect rather than absorb impacts. Every line, every angle was optimised for speed. Earl's staff even designed the Hellcat logo, a wildcat biting down on crushed tank treads, with the motto "Seek, Strike, Destroy," that would become the rallying cry of tank destroyer forces. Buick engineers initially thought the designers had lost their minds. The armour specification called for maximum thickness of 1 inch, less than half what German tanks carried. Chief Engineer Robert McCurry reportedly threw the specifications across the conference table and declared, "This isn't a tank destroyer, it's a death trap on tracks." But Charles Chain, Buick's Vice President of Engineering, recognised what others missed. If the vehicle was fast enough, truly fast enough, it wouldn't need armour. It would never be where enemy shells landed. Through the blazing summer of 1942, Buick engineers performed what military historians would later call miracles of innovation. They developed a torsion bar suspension system that provided stability at unprecedented speeds, technology never successfully implemented in an American combat vehicle. The system, adapted from European designs but refined using Buick's automotive expertise, allowed the vehicle to maintain stability at speeds that would have shaken conventional tanks to pieces. They created the revolutionary Torquematic automatic transmission capable of handling massive torque while providing smooth acceleration that tank drivers had never experienced. Every component was engineered for speed and reliability rather than brute strength. The power plant selection proved even more radical. The Wright R975, a 9-cylinder radial aircraft engine producing 400 horsepower, the same engine that powered B-24 Liberator bombers. Installing an aircraft engine in a ground vehicle required complete reimagining of cooling systems, airflow dynamics, and maintenance procedures. Buick engineers created an engine compartment accessible from above, allowing the entire engine to slide out on rails for field replacement in under 4 hours, faster than changing a transmission in a civilian truck. The design evolution moved at wartime speed. The T-42 with its inadequate 37mm gun was abandoned before completion. The T-49 mounted a 57mm gun, better but still insufficient against German heavy armour. The T-67 carried the 75mm gun used on Sherman tanks, but testing revealed need for more power. Finally, the T-70 emerged with the new 76mm gun, a weapon that could penetrate German armour at combat ranges. January 1943 brought the moment of truth. The Ordnance Department directed that 6 pilot models of the 76mm gun motor carriage T-70 be built with torsion bar suspensions, more powerful engines, new turrets, and refined hull design. The prototype that rolled out of Buick's Flint, Michigan factory that spring defied every expectation and shattered every assumption about what a combat vehicle could be. At 18 tons, it weighed less than half of a Panther tank. Its sloped armour, though thin, presented difficult angles for enemy shells. The open-topped turret, controversial but necessary for weight savings, provided unprecedented visibility for spotting targets. But it was the performance that left observers speechless. The Hellcat achieved 55 miles per hour consistently, with testing reaching 60 miles per hour on paved roads. To comprehend this achievement, consider that the German Panther tank, considered fast for its size, managed 28 miles per hour on roads. The feared Tiger tank struggled to reach 23 miles per hour. The American Sherman, backbone of Allied armoured forces, topped out at 25 miles per hour. The T-70 could run circles around any tank on the battlefield. At the General Motors Milford Proving Ground, the same facility where Buick tested luxury sedans for wealthy customers, the T-70 underwent trials that seemed more appropriate for a race car than a weapon of war. Top speed testing occurred on a paved, banked oval track. Ride quality tests involved specially developed stretches of bumps that would have destroyed conventional suspensions. The vehicle demonstrated ability to ford 6 feet of water, climb walls that stopped tanks, and ram through structures that would trap conventional vehicles. The T-70 could accelerate from 0 to 30 miles per hour in under 15 seconds, faster than most civilian automobiles of the era. During one demonstration for skeptical army brass, a test driver deliberately launched the vehicle off a ramp at 35 miles per hour. The T-70 flew through the air, landed hard, and continued driving without pause. General Jacob Devers, observing this demonstration, reportedly turned to his aide and said, "If that crew survived, we just won the war." The 704th Tank Destroyer Battalion became first to test the revolutionary vehicle. The unit had trained on the inadequate M3 gun motor carriage and approached the T-70 with deep skepticism. Despite prototypes requiring numerous improvements, the 704th compiled a superlative testing record that would influence the vehicle's final configuration. Crews gradually discovered they weren't driving a tank, they were operating something entirely new that required complete reimagining of armoured tactics. They developed the shoot and scoot technique, firing 2 or 3 rounds from concealed positions, then relocating before enemy guns could traverse to engage. They learned to use terrain features that tanks couldn't access, racing through valleys and defiles where heavier vehicles would bog down. They discovered that at high speed, the T-70 presented an almost impossible target, challenging even veteran German gunners who had never faced such a fast-moving threat. Lieutenant Edwin Leiper, who would later become one of the most successful tank destroyer commanders in Europe, wrote to his wife during training, "We're learning to fight like Apache warriors, not soldiers. Hit them where they don't expect, from angles they can't defend, then vanish like smoke before they can respond. The vehicle is so fast it feels like having a time machine. We're gone before their shells arrive where we were." The Tank Destroyer Board officially adopted the T-70 as a project on December 31, 1942. Between then and November 23, 1943, the board conducted exhaustive testing, making 16 complete reports recommending 137 modifications and improvements. Every change was tested at both Milford and Aberdeen proving grounds, with Buick engineers working alongside military crews to refine the design. The turret traverse was accelerated, gun stabilization improved, radio equipment repositioned for better protection, storage compartments added for ammunition and crew equipment. July 1943 marked the beginning of mass production at Buick's sprawling Flint plant. The factory that had produced luxury automobiles for bank presidents and Hollywood stars was now assembling tank destroyers at $55,230 per vehicle, approximately $750,000 in today's dollars. The production line, modified in just 4 months, incorporated revolutionary techniques from automotive manufacturing never before applied to armoured vehicles. By January 1944, Buick was producing 100 Hellcats monthly. By spring, production reached 200 units per month. Each vehicle required 20,000 individual parts sourced from suppliers across 17 states in a logistical ballet of extraordinary complexity. Engines came from Wright Aeronautical in New Jersey, transmissions from GM's Hydromatic division in Michigan, guns from Watervliet Arsenal in New York, tracks forged in Pennsylvania steel mills. It was American industrial orchestration on a scale that would have been incomprehensible to German planners struggling to produce 50 Panthers monthly. March 1944 brought official recognition when the T-70 was standardized by the Ordnance Department as the 76mm gun motor carriage M18. The designation came as first production vehicles were being loaded onto Liberty ships bound for European battlefields. The first combat test came May 1944 in Italy. 5 T-70 prototypes were sent to the Anzio beachhead for evaluation with the 601st and 894th Tank Destroyer Battalions. The results exceeded even Bruce's optimistic projections. In their first engagement, 2 Hellcats destroyed 5 German tanks in 12 minutes without taking a single hit. The after-action report, classified for 30 years, recorded the engagement in clinical detail. The Hellcats had used superior speed to flank a column of Mark IV tanks, destroyed the lead and trailing vehicles to trap the column, then systematically eliminated remaining tanks from enfilade positions. German tanks never successfully returned fire, their turrets unable to traverse fast enough to track the speeding Hellcats. But it was in France that the Hellcat would earn its fearsome reputation. September 19, 1944, near the village of Arracourt, would become the Hellcat's defining moment in military history. The German army had assembled its last major armoured reserve in the West, the 111th and 113th Panzer brigades equipped with factory-fresh Panther tanks. Hitler himself had ordered the destruction of Patton's Third Army, convinced that concentrated armour could drive American forces back across the Moselle River. The morning of September 19th dawned with thick fog blanketing the French countryside. Visibility was less than 30 yards. Lieutenant Edwin Leiper led one M18 platoon of C Company, 704th Tank Destroyer Battalion, toward Rechicourt-la-Petite. Through the fog, a German tank gun muzzle appeared just 30 feet away. In the next 5 minutes, military history was made. 5 German tanks of the 113th Panzer Brigade were knocked out for the loss of one M18. The platoon continued their devastating work, destroying 10 more German tanks while losing another 2 M18. One M18, commanded by Sergeant Henry R. Hartmann, knocked out 6 Panthers single-handedly. Hartmann's Hellcat, racing between firing positions at speeds approaching 45 miles per hour, appeared to German observers as multiple vehicles. Panther crews reported being engaged by an entire company when facing 4 Hellcats. By the time the Battle of Arracourt ended 11 days later, the 704th Tank Destroyer Battalion had knocked out 39 German tanks for the loss of 7 M18, a kill ratio that stunned military analysts. More significant than numbers was the psychological impact. German tank crews, accustomed to dominating battlefields, found themselves hunted by an enemy they couldn't catch or escape. The Battle of the Bulge in December 1944 provided the ultimate test of the Hellcats' capabilities in the worst possible conditions. On December 19th and 20th, Team de Sobry, a battalion-sized task force defending Noville, was supported by just 4 M18 705th Tank Destroyer Battalion. In brutal winter combat, these 4 Hellcats destroyed 30 German tanks and inflicted between 500 and 1,000 casualties on the elite 2nd Panzer Division. The Noville engagement demonstrated the Hellcat's strategic mobility. Racing at speeds exceeding 50 miles per hour on icy roads, a feat that would terrify most drivers in civilian vehicles, the Hellcats covered 60 miles in under 2 hours, arriving at blocking positions 20 minutes before German reconnaissance units even knew American forces were moving. Early combat feedback revealed remarkable mechanical reliability. Crews reported Hellcats operated hundreds of miles under combat conditions without requiring major repairs to armament or engines. The average Hellcat remained operational 94% of the time, compared to 78% for Sherman tanks and 81% for M10 tank destroyers. This reliability came from Buick's automotive engineering philosophy: build it simple, build it strong, make it easy to fix. But success came at a terrible price. The open-topped turret that saved weight exposed crews to snipers, artillery fragments, and weather. The thin armor that provided speed made Hellcats vulnerable to virtually any anti-tank weapon. Testing revealed that 9 out of 30 armor-piercing .30 caliber bullets could penetrate the turret sides at 75 yards. A German Panzer could destroy a Hellcat at 100 meters. Even heavy machine guns posed threats at close range. Yet for all vulnerabilities, the Hellcat achieved something remarkable: restoration of American armored superiority through radical innovation rather than imitation. While British and Soviets responded to German heavy tanks by building their own heavy tanks, America built something entirely different. The M18 compiled the highest kill-to-loss ratio of any American tank or tank destroyer in World War II. Total kills claimed: 526 enemy vehicles, 498 in Europe, 17 in Italy, 11 in the Pacific. The overall kill-to-loss ratio was 2.4 to 1. Buick was initially contracted to build 8,986 Hellcats, but production ceased at 2,507 in October 1944. The reduced production wasn't due to any failure, but rather the changing nature of war. By late 1944, German armor was increasingly rare, destroyed or abandoned for lack of fuel. The tank destroyer force had achieved its mission so thoroughly that it eliminated its own purpose. Lieutenant Colonel Andrew Bruce, observing Hellcat training at Camp Hood in August 1944, told his staff, "We asked American industry to do the impossible, build a vehicle that could outrun, outmaneuver, and outfight the best tanks in the world while weighing half as much. They didn't just meet the requirement, they exceeded it in ways we never imagined possible." The impact extended far beyond battlefield statistics. Oberst Wilhelm Müller, a captured German tank designer, told American interrogators in 1945, "We could not understand how you built combat vehicles like automobiles. Every Hellcat we examined was identical, parts perfectly interchangeable, systems standardized. We built each Panther like a custom watch, taking weeks for each vehicle. You built Hellcats like Ford builds cars, completing one every few hours. We could build better individual tanks. You could build more tanks, faster, and that determined victory." The human dimension often gets overlooked in technical discussions. Crews who fought in Hellcats were predominantly young men from automotive backgrounds, mechanics and hot rodders who understood engines and speed. They brought uniquely American approaches to armored warfare, treating Hellcats more like racing cars than tanks. Sergeant Michael O'Brien of the 603rd Tank Destroyer Battalion painted flame decals on his Hellcat's hull and installed a horn that played Dixie. His crew welded extra storage, modified seats for comfort, and illegally modified the engine governor to achieve even higher speeds. "We weren't tankers," O'Brien explained. "We were hot rodders who happened to be fighting a war." 640 early production M18 armoured utility vehicles were converted into M39 armoured utility vehicles between October 1944 and March 1945 by removing turrets and fitting seats for 8 men. These vehicles served as armoured personnel carriers, ammunition haulers, and mobile command posts. In Korea, M39s evacuated wounded under fire, delivered supplies to surrounded units, and provided protected mobility in harsh terrain. The international legacy extended decades beyond American service. Hellcats served in Italian, Greek, Taiwanese, Yugoslav, and Bosnian armies. The last combat use occurred during the Yugoslav wars of the 1990s, 50 years after conception. Croatian forces captured several from Serbian units and employed them in rapid maneuver warfare. The sight of World War II-era Hellcats racing through Balkan villages in 1995, still achieving speeds that modern armoured vehicles struggled to match, provided surreal testament to the original design's soundness. Post-war influence on armoured vehicle design cannot be overstated. Every modern cavalry vehicle owes conceptual debt to the Hellcats' example. The German Bundeswehr's Kanonenjagdpanzer directly copied the Hellcat philosophy. The French AMX-10RC adopted similar principles. Modern wheeled tank destroyers like the Italian Centauro trace their lineage to the M18. Lieutenant General William Dupuy, reflecting on the Hellcats' influence in 1978, wrote, "The M18 proved that victory doesn't always go to the biggest or strongest. It goes to the smartest, fastest, and most innovative. Every modern cavalry vehicle owes something to the Hellcats' example of speed over armour, mobility over protection." The industrial story deserves equal recognition. The same factory revolutionizing tank destroyer production was simultaneously manufacturing aircraft engines, ammunition cases, and countless war materials. Buick initially planned producing 500 B-24 bomber engines monthly. By 1944, they produced 2,000. Initial target for aluminum cylinder heads was 25,000 monthly. They achieved 125,000 monthly, demolishing original expectations. Mary Patterson, one of thousands of women building Hellcats at Buick's Flint plant, recalled in 1995, "I went from being a housewife to welding armor plate in 3 weeks. The training was intense but simple. They had broken every task down to basic steps anyone could learn. I personally welded hulls for probably 200 Hellcats. Everyone that came back with victory markings, I wondered if it was one of mine." The psychological impact on German forces was devastating and lasting. Wehrmacht records captured after the war reveal growing dread of Hellcat units. German tank crews, accustomed to technical superiority, found themselves hunted by an enemy they couldn't catch or corner. Major Hans Richter, intelligence officer for the 116th Panzer Division, wrote in January 1945, "The American Hellcat has created paranoia among our tank crews. They report being engaged by vehicles moving at impossible speeds. Crews refuse to advance without extensive reconnaissance, fearing Hellcat ambush. The psychological impact exceeds the actual threat, but the fear is paralyzing operations. Of approximately 10,000 men who served in Hellcat units, over 1,500 were killed in action. The casualty rate exceeded that of regular armoured units. Sergeant First Class Robert Mitchell, who survived 3 Hellcats destroyed in combat, reflected in 1990, "We knew we were rolling coffins if we got hit, but we also knew we could kill any tank on the battlefield if we were smart and fast. It was a devil's bargain, trade protection for killing power. Most of us thought it was worth it." The story reaches its emotional culmination on May 8, 1945, VE Day. In the town square of Pilsen, Czechoslovakia, a battered Hellcat of the 761st Tank Battalion sits surrounded by celebrating civilians. The vehicle bears scars of countless engagements, its armour pocked with shrapnel, tracks worn from thousands of miles of warfare. But it made it to victory. On its hull, the crew has painted their combat score, 31 enemy vehicles destroyed. Sergeant James Washington, who commanded that Hellcat, returned to Pilsen in 1995 for the 50th anniversary of liberation. Standing before a memorial to the 761st, he said, "The Hellcat was America in steel, quick, clever, and deadly when cornered. It wasn't perfect, but it was perfectly American. We took a crazy idea, a tissue paper tank that could outrun anything, and made it work through sheer determination and industrial muscle." In just 15 months of production, Buick built 2,507 Hellcats. Each vehicle contained 20,000 parts from 186 primary suppliers and over 1,000 secondary suppliers across 38 states. The production line, operating 3 shifts 24 hours daily, never stopped except Christmas 1943. At peak production in January 1944, a completed Hellcat rolled off the assembly line every 3.2 hours. William Knudsen, former president of General Motors who coordinated war production, testified before Congress in 1946. The Hellcat program demonstrated American industry at its absolute peak. "We took an impossible requirement: build a tank destroyer that weighs nothing, costs little, and can destroy anything, and delivered a vehicle that exceeded every specification. It wasn't just manufacturing, it was alchemy." The philosophical implications challenged military thinking worldwide. Traditional doctrine emphasized mass, firepower, and protection. The Hellcat proved that speed, agility, and precision could overcome brute force. General Don Starry, architect of airland battle doctrine, wrote, "The Hellcat proved that technical overmatch doesn't require superior weight or armor. It requires superior thinking, superior tactics, and the courage to accept risk for advantage. Every modern operation plan that emphasizes speed over mass owes a debt to those tank destroyer crews. Even former enemies acknowledged its revolutionary impact." General Heinz Guderian, father of German armored warfare, wrote in his memoirs, "The American M18 represented a philosophy we should have adopted. Instead of building heavier and heavier tanks that stressed our logistics and industry, we should have built faster, simpler vehicles in greater numbers." The Hellcat proved that tactical mobility beats armor protection if properly employed. Of the 2,507 built, fewer than 200 survive today in museums and private collections worldwide. Each restoration requires painstaking effort to source parts that haven't been manufactured for 70 years. Jacques Littlefield, who owned the world's largest private collection of armored vehicles until his death, spent $400,000 restoring a single Hellcat to perfect running condition. He explained, "The Hellcat represents everything right about American engineering: bold, innovative, and effective. Every rivet, every weld tells the story of workers who built freedom's arsenal." At the final national reunion in 2015, 93-year-old former Staff Sergeant Vincent Romano, one of the last living Hellcat commanders, gave the closing speech. "We were kids driving hot rods in a war of giants. Our Hellcats were tissue paper compared to tigers and panthers, but we had speed, we had guts, and we had each other. We proved that American kids in American machines could beat anyone, anywhere, anytime. Not because we were stronger, but because we were smarter and faster." The role of women in Hellcat production deserves special recognition. Over 40% of the workforce building Hellcats were women performing jobs previously reserved exclusively for men. Rose Thompson, who supervised an all-female welding team, recalled, "They told us women couldn't build tanks. We built the fastest, most effective tank destroyer in the war. After that, nobody could tell us what women couldn't do. The Hellcat didn't just beat German tanks, it helped beat prejudice at home." General Omar Bradley, in his autobiography, captured the Hellcat's essence. The Hellcat was quintessentially American, unconventional, innovative, and devastatingly effective. It represented our approach to war. We didn't try to match the enemy. We tried to make him irrelevant. The M18 made heavy tanks obsolete, not by being heavier, but by being smarter. In 1973, Andrew Bruce, then 79 years old and long retired, visited the Patton Museum at Fort Knox. Standing before a restored M18 Hellcat, he spoke to a group of young armor officers. "Everyone told us it couldn't work. Too light, too thin, too dependent on speed. The armor board said it would be a death trap. The ordnance department said it was impossible to build. The tactics we proposed violated every principle of armored warfare. But we built it anyway, and it worked beyond our wildest dreams. The lesson isn't about tanks or tactics. It's about having the courage to challenge conventional wisdom when conventional wisdom is failing." The M18 Hellcat stands as one of the most remarkable achievements in military history. From the panicked recognition of American unpreparedness in 1941 to the victory celebrations of 1945, it traveled a path that seemed impossible. Born from defeat at Kasserine Pass, designed in defiance of military convention, built by an awakened industrial giant, and proven in the crucible of combat from Anzio to the Rhine, the Hellcat demonstrated that innovation could overcome any disadvantage. Today, in museums around the world, surviving Hellcats stand silent, their engines cold, their guns empty. But they still speak to anyone who will listen. They tell of American workers who built the arsenal of democracy one vehicle at a time. They speak of young men who fought with courage despite inadequate armor, knowing speed was their only protection. They speak of engineers who chose innovation over imitation when conventional thinking meant certain defeat. They speak of a nation that turned its industrial might into military victory through sheer determination and creative genius. The rejected design that nobody wanted became the most successful tank destroyer in American history. The vehicle that was too light, too fast, and too unconventional proved that sometimes the best solution is the one nobody expects. In the speed of the Hellcat was written the future of armoured warfare. In its success was proven the power of American innovation, and in its story lies a lesson for all time. When facing a superior enemy, don't try to match their strength. Instead, render their strength irrelevant through superior thinking, superior speed, and the courage to do what nobody believes possible. The M18 Hellcat was, in every sense, the weapon that won through speed, the tank destroyer that redefined what was possible, and the rejected design that saved countless Allied lives through the simple expedient of being where the enemy's shells were not. It remains, 80 years after its conception, a testament to American ingenuity, industrial might, and the power of thinking differently when different thinking is the only path to victory.